To make the chuck I used some plywood that I had knocking around. It wasn't thick enough, so I had to glue it together to the required thicknesses for the 3 blanks that I'm going to make. Most 4-jaw chucks today come with a screw to convert the 4-jaw chuck into a screw chuck. As it turns out that the screw that come with the chuck was too long, so I put a packing piece in to reduce the penetration of the screw into the wood. I have a number of these thin plywood templates to suit all the different sized jaws of the various chucks that I've acquired over the years. Saves a lot of time. I could have used a spindle gouge for turning the outside diameters of the blanks, but a bowl gouge is more sturdy and seems to leave a better finish more quickly. If you don't, the insert nut will stop before it reaches the tip because it only goes as far as the maximum diameter in the hole. Rather than put a countersunk in the end of the Jacob's chuck and then using the tailstock, I've just created a countersink using my parting tool. With insert nuts it's very easy to put them in out of true, so I'm using an old bit of scrap wood and the tailstock to true them up and just give it a start and then use an Allen key to finish the job. With all the holes I'm going to put into the base blank, make sure that they're all countersunk and that the head of the insert nut goes in below the surface of the timber. I previously made a drawing on the computer and printed it out in the positions of the next holes. There's 11 of them, 12 in total, and I'll put a link to the drawing in the description of this video. I'm using a sharp pointed brad awl here to position the points of the hole, and then use a brad point drill to line up with the dimples I've created. To drill the pilot holes I'm using the Axminster drill guide. It's quite cheap, and it's amazing how often I've used it on the lathe and off it. In order to set the depth of the pilot holes, I'm putting a tape on the top part of the drill that touches the metal bush that goes into the plastic guide. I've measured the depth of the insert nut with the vernier caliper, and using the depth gauge part of the caliper to set where I'm going to position the tape on the drill. I always use a brad point drill, which in this case is a 4mm diameter, to locate the dimples I've made with the brad awl. It's far easier than trying to line it up with the plastic guide resting against the wood first. The magic of video editing has removed the length of time that I've took to drill the holes, and I'm now in the process of enlarging the 4mm diameter holes I've drilled with the drill guide, and using a 9mm standard drill to enlarge the holes. Now it's a matter of countersinking the 9mm diameter holes so that the head of the threaded insert nut goes below the surface of the wood. To make sure the threaded nuts going vertical to the surface, similar to that on the lathe, I use the vise just below to start the the insert nuts off and then finished off with an Allen key as I did on the lathe. Here I'm using the edge of metal rule to make sure that none of the heads of the threaded insert nuts protrude beyond the surface of the wood. Back to using the screw chuck in my 4-jaw chuck to turn the outside diameter and the spigot of the indexing blank. I partly turned the outside diameter of the blank about the half the thickness and then reversed it in the chuck and blended it together on the outside diameter. Here I'm just inserting another insert nut, just the one, in the centre of the indexing blank. Here I'm creating a spigot 10mm long and by approximately 10mm smaller diameter than the outside diameter of the blank. It's an arbitrary size, you can make up your own. And here I'm going to put the indexing holes using the indexing jig at a later stage. In order to fix the indexing blank to the base blank using the pre-drilled holes I've made, I've cut off a 6mm stud from a 6mm X bolt I had. Here I'm just testing that the indexing blank sits properly and locks in a good solid position onto the base blank. If you have a small lathe that you're going to use these DIY chucks on, make sure that you don't get too ambitious at the size of them, because the more eccentricity you create, the more vibration you're going to get. Even in this situation, I had to screw the lathe to the bench and the bench to the wall to stop uncomfortable vibrations. To make the indexing holes in the indexing blank, I'm going to use my indexing jig, which I made in a previous video some time ago. There'll be a link to that video and the subsequent drawings in the description of this video. I've selected a disc showing 12 divisions to suit the 12 holes in the base blank of the DIY chuck. Here I've reverted back to the inserts of the Axminster drill guide, which goes in the tool post. I'm using a 4mm diameter brad hole point that comes with the set of the drill guides to mark the positions of the hole. The reason I'm doing that is so that the brad point of the drill which will follow to drill the actual proper holes themselves line up with the dimples that I've made with the brad. This is far easier and there's less chance of error. When drilling the holes using the cordless drill, I've set the drill to such a position in the cordless drill so that when the cordless drill tip touches the metal insert into the tool post, the correct depth of hole is drilled. I'm turning the outside diameter of the end cap to suit the outside diameter of the indexing blank. Here I'm creating a recess in the underside of the cap to suit the spigot on the indexing blank. Here I've had to cut a few frames of the video at the point where I'm hollowing out the recess because my flipping head got in the way. Sometimes I get carried away and I don't realise I've obstructed the view of what I'm doing. I still haven't quite got the position of the cameras right. Anyway, I'll soldier on. Hope it doesn't spoil the content of the video too much. Now I've achieved a nice push fit of the end cap into the indexing blank. I'm going to put a fixing hole dead on centre to put a countersunk head screw which will locate into the indexing holes I've made in the indexing blank. This procedure can be quite fiddly, lining up the indexing holes with the single hole I've made in the end cap. So I've used a slightly smaller drill to locate the holes. When trying to tap wood it's very difficult, especially plywood or softwood, you've no chance. So the ideal thing is to use a very dense timber like beech or hornbeam or holly. Well, they're a bit difficult to get hold of in the sizes you need. So the idea is to drill a hole to the size of the tap, the thread you're going to tap, and then fill it with araldite, re-drill the hole again to the minimum diameter that's required for the tap, and then use the remaining araldite surface to create a thread. Once I've tapped all the holes in the indexing blank, it's just a matter of creating a countersunk in the end cap hole so that the machine screw, the countersunk head machine screw, goes below the surface of the end cap diameter. With a DIY chuck like this that's fitted into a manufactured forge-jaw chuck, you want the projection from that chuck as minimal as possible. So when you're designing your DIY chuck, try to keep the components as thin as possible, so there'll be less chance of awkward vibrations at a later stage. Here I'm just parting off about 5mm, something like that, to secure a thinner chuck. Here I'm making the surface flat as possible, which if I want to put some wood that I want to do some turning on, I can use double-sided tape and it will adhere to a flat surface far better than a concave one. So make it as flat as possible. When turning eccentric work, the chuck at the moment only really caters for a thin broach, which will be double-sided tape to the flat surface I've just created. To do longer work, I need to convert it to a screw chuck, so I've used an old wood screw, took the head off and tapped the top of it at 6mm so that it'll screw into the indexing blank. Well, here it is, the eccentric chuck, or eccentric jig if you like, for turning small eccentric work. Now you can make it bigger for a larger lathe, it'll still work on a larger lathe, but as I indicated earlier, if you're going to use it on the small lathe like the Axminster one, which most of my videos cater for, make it as small as you can. It's only a little lathe and it can't absorb vibration too much. When inserting the screw to convert it to a screw chuck, it was quite fiddly to line up the thread with the thread in the indexing blank. It was a bit fiddly into getting it to seat properly, and overall I thought I needed another hole in the end cap because there was some movement, and the countersunk screw wasn't holding it tightly enough. So I've done a second modification. I made another one to iron out those problems. I've also added an aluminium disc so that I don't have to keep removing double-sided tape from timber all the time, and aluminium disc would be more durable when you keep taking off and replacing double-sided tape. The second eccentric chuck I've made out of beech. It's far easier to put a thread on that will hold the end cap on in the indexing holes. The number of holes is slightly different. I've put 10 on this for some reason, and I've created 10 marks on the outside diameter of the indexing blank and the corresponding mark on the cap to record the positions and create an indexing system within the chuck itself. I've also widened the entrance hole of the old screw chuck so that I can just screw it directly through the aluminium face plate.